Hi all, this is your guided practice 7 on section 2.5, solving other equations. So we're going to take a look here and look at number 1, and this is absolute values. So remember that when we solve something with absolute values, the first thing we do is get the absolute value part by itself. Right now this 5 is also with the absolute value, so I want to get rid of that. So let's subtract a 5 from both sides. That's going to give me absolute value of 3x minus 2 equals 1. Okay, now to take care of the absolute value part, I split this into two equations. So I'm going to take the 3x minus 2, the argument of my absolute value, what's inside there, and set it equal to 1. And I'm going to take 3x minus 2 and set it equal to negative 1. And then I solve each of these two equations. So I'm going to add 2 to get 3x equals 3, and divide by 3 to get x equals 1. Okay, we can check to see if that works. When you plug it in, 3 minus 2 is 1. Square absolute value of 1 is 1, plus 5 is 6. So that works. Check. Over here, we're going to add 2 to get 3x equals positive 1. And we're going to go ahead and divide by 3 to get x equals 1/3. Now, does that work? Well, if we take x equals 1/3 and we plug it back in, 3 times 1/3 would be 1. Minus 2 is negative 1. The absolute value of negative 1, we make it positive. So positive 1 plus 5 gives us 6. So both of those are good answers. Now, number 2, take a look at this. This looks like quite a bit, right? There's lots of radicals here, which probably means we're going to have to do things more than once, okay? And we'll get to that in a second. Right now, you can see that this big radical right here is all by itself, right? There's more radicals flying around, but there's a big one with a radical inside, and so I want to set that one by itself, and it already is. So we're going to go ahead and square both sides. On the left, that gets rid of my square root, so I have 1 plus 4 root x over there. And then I'm doing root x plus 1 times root x plus 1. Well, root x times root x is going to give me just a plain old x. When I multiply the inside and the outside, there's a square root of x there twice, so that's plus 2 root x. And then 1 times 1 is plus 1. Okay, now I'm going to try to do the same thing again. So I'm going to try to get a single radical. Notice that these two are like terms, and these two are like terms. So let's go ahead and combine some like terms. So let's go ahead and subtract 1, and let's subtract the 2 root x. So my 1's are going to cancel, and then 4 root x minus 2 root x is going to be 2 root x. On the right, everything canceled except the x. Now I'm going to solve for that radical. I'm going to get it all by itself. So I'm going to divide by the 2 first. And that gives me root x equals 1/2 x. And now that that radical is all by itself, now I can go ahead and square both sides. Square root of x squared is just going to be x. And over here we have 1/4 x squared because we're squaring both things. So 1/2 times 1/2 is 1/4, and x squared is x squared. Now I want to go ahead and solve this. So I'm going to actually clear my fractions. I'm going to multiply everything by 4. And that gives me 4x equals x squared. I'm going to go ahead and subtract the 4x to the other side. So I'm going to subtract 4x. But I'm also going to flip it around. So that'll make it x squared minus 4x equals 0. And now I can factor. These two have an x in common. When I take it out, I have x times x minus 4 equals 0. And now I can split. This one I set equal to 0, and I get x equals 0. And then over here, I have x minus 4 equals 0, which will give me x equals 4 if you add 4 to both sides. Okay. Now we do want to check that both of these actually work. So let's check x equals 0. So if I plug that in, I'm taking the square root of 1 plus 4 times the square root of 0, and the square root of 0 plus 1. So on the right, that's just 1. Over here, the square root of 0 is 0 times 4 is 0. So I have just the square root of 1 underneath the radical, and that's just going to give me 1. So that one does work. Then let's check our x equals 4. So we want the square root of 1 plus 4 root 4. And that should be equal to the square root of 4 plus 1. So if we do that, this is square root of 1 plus 4. Square root of 4 is 2. 2 plus 1. Then this is the square root of 4 times 2 is 8 plus 1 is 9. And 3 over here. And that does turn out correctly. So they are both solutions, and those are both good to go. Okay, so that one where you have multiple radicals, sometimes squaring things once isn't enough to get rid of all your radicals. Okay, you're going to have to do it more than once. That's okay. You're going to complete the process. So if you square both sides, there's still radicals. You're going to isolate a radical, right? And then square again. Let's take a look at this one. In this case, I've got two radicals, one on the left, one on the right. This one's already solved for the radicals, so we're ready to go. Let's go ahead and square things and see what happens. On the left, you're squaring the first term. So if you want to write it out, you can. Square root of 2x plus 15 minus 2, and the same thing again. So square root of 2x plus 15 minus 2. When you do that, when you multiply the first two, the square root goes away and you get 2x plus 15. In the middle, you're going to get negative 2 times that square root. On the outside is the negative 2 times that square root, so it's negative 4 times that square root. And then negative 2 times negative 2 is positive 4. On the right, we have what's inside because the square root and the square cancel, so x plus 1. All right, now I'm going to work to isolate this radical because it didn't go away. That's okay. I'm going to work to make it go away. So I'm going to subtract 2x from both sides. I'm going to subtract 15 from both sides. And I'm going to subtract 4 from both sides. And that's going to leave me with negative 4 square root of 2x plus 15. 6x minus 2x is 4x. And negative 15 minus 4 is negative 19, plus 1 is negative 18. Then we can go ahead and divide. Actually, let's leave it. Let's go ahead and square both sides. You can divide by that negative 4 if you like. Okay, but let's go ahead and square both sides. When you square the negative 4, that becomes 16. And the square root cancel, and that's 2x plus 15. And on the right, we get this quantity squared. So 16 squared, x squared. Multiply the 2 and double. So negative 18 times 4 times 2. So I'm taking 8 times 18, which is 144. So minus 144x. And 18 squared is 325. So plus 325. If you need to write that out so you can get all those, please do. And then we're going to go ahead and distribute. Actually, yeah, let's go ahead and distribute. Because, actually, hold on. Whoa. This is not a 5, it's a 4. Now, all of these are divisible by 4, so I am going to go ahead and divide everything by 4. Maybe that'll make our numbers easier. So that's 4 times 2x plus 15 equals 4x squared. Let's see here. 144 divided by 4 gives me 36, so minus 36x. And 324 divided by 4 gives me 81. Now, I wanted to divide through by 16, but it wouldn't go in evenly, and then I'm going to end up with fractions, and I really don't want fractions. Now we can go ahead and distribute. So let's distribute this 4. That'll leave us with 8x plus, 60. And 4x squared minus 3x plus 81. And now we're back to a quadratic equation from section 2.3. So let's combine our like terms. So let's go ahead and subtract an 8x and a 60. And then I'm running out of room, so I'm going to go this way. That's going to give us 4x squared. 36 minus 8, they're both negative, so that's going to be negative 44x. And 81 minus 60 is plus 21. All right, let's see if it's factorable. So we would go box and circle because there's a number out front and it's 3 terms. So 4x squared here, 21 here, gives me an 84 in the box. Factors of 84 that add to 44. Let's see, if I take a 2 out of there, I'm going to factor tree this a little bit. If I take a 2 out, that's 42. Ooh, and that would give me 44 if they're both negative. So that works out nicely for us. So I put the negative 2x here and a negative 42x here. Then we can go ahead and factor the box. So there's a 2x in common up top row. When you take the 2x out, there's a 2x here. When you take a 2x out of the negative 42x, you're going to get negative 21. And the negative 2x and the negative 21. When you take a negative 2x out of the top row, this would be a negative 1. And then your 21 works properly. So that means we factor this as 2x minus 1 and 2x minus 21 equals 0. Then we can go ahead and split this up. So this one will become 2x minus 1 equals 0. Add 1, divide by 2, and you'll get x equals 1/2. This one, we get 2x minus 21 is equal to 0. Add 21 to both sides, divide by 2, and you get 21 over 2. Okay. Quick check to make sure everything works. When you plug in 1/2, we get 16, which is 4 minus 2, so we get 2 on the left. And 1/2 times 6 is 3, plus 1 is 4, root 2 is 2. That one works. Let's see, 21 over 2 times 2. 21 plus 15 is 36. Square root of 6 minus 4 gives you 4. And I'm just plugging into the original equation here real quick. Let's see. Times 3 would give me 63 plus 1 is 64. Square root of 64. Hold on, let's do this one a little slower. When you plug in 21 over 2. Because I think this one might not work. Let's check it. So 2 times 21 over 2 plus 15 minus 2. And over here, square root of 6x plus 1. Instead of the x, we put in our 21 over 2. And then plus 1. Okay. Over here on the left, the 2's will cancel. 21 plus 15 is the square root of 36. Square root of 36 is 6, which gives me the 4. That's how I got the 4 earlier. Over here, this 2 cancels and I'm working with a 3. 3 times 21 is 63. Plus 1 is 64. And if we take the square root of that, we get 8. So notice that that one does not work. So we're going to throw that answer out. Okay, and just something about the way that that happened to make that not work. Okay, and that's going to happen sometimes with your square root, so we should always check them. All right. Last but not least, number 4. If I rewrite this, this represents the square root of x to the 5th and the square root of x cubed. And I have both radicals isolated, so I can go ahead and square both sides. That's going to give me x to the 5th equals x cubed. And I'm going to subtract an x cubed over to the other side. That gives me x squared equals 0. And that then you can take the square root of both sides. And you get x equals 0 as your only answer there. Because 0 can't be plus or minus. And when you plug that in on both sides, that one does work. So that one's kind of quick and easy.